All right, thank you. So hi everyone. So welcome to our June 2nd APAC community call. So as advised, we will be, so here's our quick agenda. We'll first again go through the OHDSI news, which we will have, I'll share later about some of the network studies that you may be interested. And then the majority of the part, we will have the tutorial on incidence and prevalence calculation by Patrick. So first, I will share the OHDSI news part really quick. I think it's really just a FYI for everyone that we just had, I think early, not this week, but last week, we had the global community call where I guess it's May 21st. So folks have shared kind of what are the network studies that are ongoing. So because I think folks here probably are already very familiar with the four kind of the APAC ones that we do have here, from Nicole, Chan, Ivan, and Changsu. But then we also have, because I know autoimmune has been popular too. So there is a IBD characterization project, and then the other, the DGEM on the prediction part that's also kind of ongoing now. Oh, can everyone hear me fine? Okay. So that would be kind of another two that was shared really kind of end of May, that if you're interested, feel free to kind of watch the recordings here. It's kind of very high level introduction, and know those studies are kind of in the starting initiation stage. So it's definitely not too late to join or anything like that. So please, so there are the 6 ongoing network studies. So if you're interested, feel free to take a look at here. So that's for the quick OHDSI news for today, and then I will switch over to the deck. So next we will have really the main part for today's community call is we'll have Patrick here also joining us live to talk about incidence and prevalence calculation. So I actually prepared this bio from Patrick. I do have one quick question, Patrick. Why I always wanted to ask, but what's the background? It looks fancy. You have the laser saying.
So in the 1980s in the US, it was popular that when you got your picture taken in high school or like elementary school, that
Okay.
children were allowed to basically choose, or their parents had to choose, the background for their photo in a yearbook. And it was a popular thing for like a couple of years in the 80s to have this laser background, which now is mocked as a very, very silly thing. And so when I had to get a bio picture for something serious, I think it was like an FDA meeting, I had one of my friends create this as a fake picture, and to see whether or not the FDA would actually print it in their briefing book as like a real picture. And sure enough, they did. So now it's stuck that that this picture of me with a crazy background is now my official biopic.
Got it. Because I always wanted to ask, because it's on the OHDSI website. I've seen it like in other situations and all that, but cool. Yeah, so thank you so much, Patrick, who is also, I'm still gonna do it. Who you probably everyone knows Patrick, and he's the VP from Incidence Research and Development, and also assistant professor in Columbia, and also of course the VP for OHDSI. So that's everything we have. And then next we will actually play a short video, not sure, but like a video on the actual kind of lecture portion. So if you could, maybe we can start kind of playing the lecture portion, and then we will pause for live Q&As, if anyone have questions.
Yeah, sure. Let me share my screen.
All right, thank you.
And as you're doing that, as the video is being played, if anybody has any questions and they'd like to post them to the chat, please feel free to do that, and I'll be watching that and happy to answer questions.
Thank you, Patrick.
So I'm gonna play the video for like 2 seconds. Please let me know if you hear the sound, because sometimes the sound is not transferred to everyone. So let me try.
So thanks everybody for.
Okay, great. I'm gonna play from the beginning, right? Enjoy the enjoy the show for about 20 minutes. I will pause once Patrick's first part of the lecture is over to take any questions. All right, enjoy.
So thanks everybody for putting up with me a little bit tonight. So on the last APAC steering committee discussion, one of the topics that's come up across all of the studies has been about how we can standardize our approaches for estimating or characterizing incidence and prevalence across various studies. I had volunteered to come to just provide a overall conceptual overview about how we have been thinking about characterizing incidence rates and incidence proportions and prevalences, to talk about the conceptual difference between those, but then also to show you how to use OHDSI tools to perform those analyses. I probably am going to have about 20 minutes of content here to walk you through the conceptual definitions as well as how to implement them, and then I'm hoping that we can have some time for discussion about what we want to be doing within each of the APAC study teams, about what we actually are trying to characterize and to make sure that we're using the right tools for that. So please do use the chat or raise your hand to let me know if you have any questions along the way, or just feel free to unmute yourself and scream out if anything I say doesn't make any sense. All right. So I'm going to start first by talking about incidence and incidence rates, because this is one of the primary metrics that we have been computing across a lot of different OHDSI studies. So an incidence rate is the number of new outcomes within a defined time at risk divided by the person time within a population at risk. And so the incidence rate is a statistic that uses time as its denominator, and it counts up the number of successive events that has occurred within some sort of time at risk. Now, very often people will get a little bit too casual with the use of their language and they will talk about incidence, but it's important to highlight that there are two different metrics when someone uses the word incidence. There is the incidence rate, which is what I just defined, and then there's also an incidence proportion. And an incidence proportion is defined as the number of persons with a new outcome within a defined time at risk, divided by the number of persons with at least 1 day at risk within the population at risk. And the distinction between these is actually, it's somewhat subtle, but it's actually important as we are trying to choose a metric. In an incidence rate, we are counting the number of new events, and that actually means that one person could have multiple events. And we're dividing that by a unit of time, so it's usually like person years, as something that we try to measure within the population. In an incidence proportion, we are both the numerator and the denominator are in units of people, where the numerator could be number of persons with a new outcome. What that typically means is that one person can either have a new outcome or could not have a new outcome, but it's a binary state. And that denominator is basically the number of people just that are eligible, which just means that they have at least 1 day of time at risk. Neither of these are right or wrong in terms of incidence measures, but they are different metrics. They are on different scales. And depending on what kind of comparison you are trying to make, there may be reasons and arguments for these. And part of the reason I want to make sure that there's plenty of time at the end is to talk about your specific studies and what metrics might actually make sense. The one thing that's similar between an incidence rate and an incidence proportion, though, is this notion of trying to identify new outcomes. And that's quite different from prevalence, which I'll get into in just a minute. Now, I'm starting here with incidence as the quantity of interest in an incidence rate and an incidence proportion, because it turns out that this happens to be the more complex of the epidemiologic measures to do correctly, and often, very, very often, certainly greater than 90% of the literature that I read, there are details associated with how to compute an incidence that aren't always shared or not necessarily done correctly. So I want to describe why this is kind of complex, just so that you all have a conceptual understanding of it, and we can think about what that means for your studies. So if you were to pick up any basic epidemiology textbook, you'd probably see some sort of picture like what I'm about to draw here when they're trying to describe the idea of incidence. What they would usually show is that there's some set of individuals who are followed for some period of time. Here I'm depicting this on the x-axis is calendar time from 2017 to 2020. And you'll usually see this picture in a textbook where it shows like 3 people start at 2017, they're followed until such time that some of those people have the outcome, which I'm depicting by this red star. And in this particular case, if I were to think about the incidence proportion, well, we can see that we had 3 individuals and one of them had an outcome, so our incidence proportion could be 1/3. The way that we would compute an incidence rate is that we would identify that there was one new outcome, that's the red star, and we would see that that was during this time horizon of 3 years at risk. What would happen is that the first person would contribute 3 years of time at risk, the second person would contribute 3 years of time at risk, but the third person would only contribute 2 years of time at risk, because once the new outcome has happened, that person can be censored and therefore not observed to have subsequent follow-up time. And like I said, if you pick up pretty much any of the epi textbooks back there on my bookcase and you're to flip to the page that describes incidence, this is kind of the picture that you generally see that they describe it as. It turns out within our electronic health record data systems and all the databases we have across the OHDSI network, there are a lot more confusing situations that we actually have to consider when we calculate incidence. For example, not everybody starts or ends their observation period on exactly the dates that we're interested in. So here's an example of a person I'm drawing whose observation period start is after the time at risk start, and their observation period end is before the time at risk end. And we have to consider whether or not we would allow for a person who does not have full time at risk to be considered in a study. Oftentimes with incidence rates, we would allow such a person to contribute the time that they have available. We also have the situation where a person could actually enter and exit the population at risk multiple times. So many of you have databases where a given person could have multiple observation periods. For example, if you're working with a hospital data source where you have an observation period defined by the periods of time when someone's admitted and discharged, and a person could come back to the hospital multiple times. In that case, one person could have multiple entries into your cohort. It's also possible that since our definition of a new outcome is some event that occurs, then it's possible, depending on the outcome, that you might allow for the possibility that a person could have recurrence of an event, in which case there's some moment in time when an event happens, there's some period of time where we would consider that person to be ineligible for a new event, and then there's some subsequent time when they become at risk yet again. And so this notion that an outcome has a clean window that could be applied inside of an analysis is a consideration. We also have the possibility that outcomes recur, which means that one given individual could contribute not only multiple periods of time at risk, but actually could contribute multiple outcomes. So if our numerator is the number of outcomes, then it's possible that one person can contribute multiple times. We will see in our data the situation where some people will have prior events, and that may impact their eligibility. So for example, this person that I'm drawing has an outcome that precedes the time at risk, and that clean window associated with the outcome overlaps the entire time that that person is potentially at risk, which means that that person may need to be excluded from the incidence analysis. We also can have a situation where we define a time at risk for a given outcome, and outcomes may fall outside of the time at risk relative to our cohort entry. So for example, if we are saying looking for outcomes that occur within 90 days of an exposure, then any outcome that's longer than 90 days in the side of the exposure, we may see them in our data set, but we want to make sure that we don't count them. And then to make all of this way more complex is that different people have different characteristics. So we have, different demographics, different prior conditions, different health behaviors, and all of this stuff will actually potentially influence our estimate of an incidence rate. So in this particular case, if I was taking all of this cartoon into play, I would have to exclude the person who does not actually contribute any time. I do not count the outcomes that are outside of the time at risk, but what I can see is that I do observe 4 new outcomes who are contributed from 3 different persons, and I can count up the lengths of these blue bars to calculate the time at risk, and that would give me my incidence rate. Or, given the exact same data set, I could calculate an incidence proportion by counting the number of people with a new event, that'd be 1, 2, 3, and dividing that by the number of people who had at least 1 day at risk, so that would be 1, 2, 3, 4, 5, 6, 7, not excluding this person, 8, 9. So now my incidence proportion would be 3 persons over 9 persons. And that metric will be quite different than the incidence rate metric, which is incorporating number of outcomes and person time. So the reason I'm going through this kind of somewhat complex detail here is because we often use incidence rates in lots of our analyses, and most commonly we are making comparisons between incidence rates. So the most common thing when people say they want to produce an incidence rate, it's usually because they want to compare, excuse me, some observed incidence rate that they've defined with some sort of expectation that they're going to use to make a comparison. And formally, if you have incidence rates, then the dividing an observed incidence rate by an expected incidence rate, this is an incidence rate ratio. And indeed, if we are doing some sort of causal inference, we have measures that actually produce this adjusted incidence rate ratio as the statistic that we're interested in. And since we're talking about causal inference, then we need to be considering all of the typical concerns about what is the appropriate epidemiologic design to estimate these incidence rates, as well as to think about the sources of bias that can occur when estimating an incidence rate, such as issues about measurement error, selection bias, and confounding. But regardless of whether you're talking about an incidence rate or an incidence proportion, there's oftentimes some sort of element of comparison that one wants to make when they're producing an incidence rate, so that they're trying to draw some inference. Examples, studies of the OHDSI network where we've done incidence includes our work last year that was published in the BMJ led by Jingteng Li, where we estimated the incidence of the adverse events associated with COVID vaccines, and that the incidence rates that we computed were based on background rates that preceded COVID or the vaccination practice. And those background rates were used in comparisons with the observed incidence rates that was observed amongst people who were vaccinated. And so both on the US side at the FDA, as well as on the European side with the EMA, they are relying very heavily on an incidence rate ratio comparison between an expected background incidence rate and the observed incidence rate amongst those that are vaccinated. And so we've honestly contributed those background rates to the FDA and the EMA to support their safety surveillance activities. So I went through incidence rate there pretty quickly. I'm now just going to highlight prevalence. So I want to contrast an incidence proportion, which is what I've previously discussed. That's the number of persons with a new outcome within a defined time at risk, divided by the number of persons with at least 1 day at risk in the population at risk. In contrast, a prevalence also is a proportion. So that means its unit is measured in persons. And here what we define is our numerator is the number of persons who have a condition within a defined time at risk, divided by the number of persons with at least 1 day at risk within the population at risk. So I'm trying to color code this to try to highlight some of the similarities and differences. The first difference you'll notice is that the numerator is slightly different because incidence is trying to focus on persons with a new outcome, and prevalence is trying to focus on people who have a condition. So to make this clear, the difference here is that a prevalence is trying to find persons who have a condition, and that is the combination of people with pre-existing disease plus people with a new outcome. So a prevalence is most often used in the context of thinking about chronic diseases, where we want to ask a question like, what proportion of a population actively has some chronic disease? So this makes a lot of sense if we're thinking about like a chronic disease like multiple sclerosis, where we are not only interested in those who develop multiple sclerosis within a time horizon, but we're also maybe interested in those who actively have multiple sclerosis, so were previously diagnosed and still maintain that disease state. So an important difference is whether or not you care about pre-existing disease in your study. Another difference between an incidence proportion and a prevalence is how we define population at risk. And specifically, while we've described in both of these, we said we've defined it as population at risk, who is at risk is actually can be different between an incidence calculation and a prevalence calculation. So a population at risk excludes people who are not eligible to be part of the numerator. So in this context, that can mean excluding persons with pre-existing disease if you're doing an incidence calculation. Because in order to have new outcome, that might mean you cannot have previously had previous existing condition. Whereas in a prevalence calculation, you would actually want to include the people with pre-existing disease because they're part of the numerator that you're trying to characterize. So with this in mind, one of the things that I want to make sure that we spend most of our time today talking about is what specific measure are we looking for? Are we interested in an incidence or a prevalence? And then we can talk about what metric we want to use, whether that be an incidence rate or an incidence proportion, or in the context of a prevalence, it will be a proportion, but we can make sure to define our numerator and denominator correctly. One last thing, and then I'm going to stop and ask if there's any questions. Within OHDSI, we have a variety of tools that support calculating whether you're interested in an incidence rate or an incidence proportion or a prevalence. We have tools to support this activity, and I'm happy to walk through a live demo to show you exactly how this is done using the tools today. But I'll just give you kind of the super quick cheat sheet for how to think about this. If you are interested in an incidence rate, in an incidence proportion, and your outcome is a chronic disease that basically can't recur, so I think multiple sclerosis would be a good example of that, insofar as I understand what the team's interested in. Then there are two ways that you could calculate this, and you will get the same answer. If you are inclined to want to use our web interface, then inside of Atlas, there is a function called incidence rates, and it will in fact compute for you the incidence rates and incidence proportions, so long as you can define your target population, which is kind of your denominator of the people at risk, and can also define a cohort of your numerator, which are the people who have the new outcomes. We also have an R package available out on the OHDSI Git repo called Cohort Incidence. And so if you prefer to just write directly in code in R, you can call the Cohort Incidence package and execute basically by passing in a target cohort and an outcome cohort. And you will get the same results between these two packages in this simple case. If, however, the outcome that you are interested in is something which is an acute event that can potentially recur. So the example I'm providing here is like influenza, where every season you have a chance of getting influenza. So therefore, we would not want to consider that to be a disease state that once you have it, you're stuck in the state of having influenza forever. But rather, we would think of it as a state that can come and go repeatedly. Then you should not use the Atlas incidence rate tool because it makes an assumption about the fact that your incident case is really the first occurrence of an outcome. Rather, you should use the R package, cohort incidence, because explicitly it was developed to handle these extra cases where a person may come and go into the target cohort multiple times and may have the outcome occur multiple times. And so the cohort incidence package is a more generalized framework for estimating incidence. Eventually, like hopefully relatively soon, that feature will make its way back into Atlas, so it's also part of the web app. But for right now, if you are looking to produce an incidence that is based on acute events that can recur, then we would recommend that you do that through the R package cohort incidence. If you are interested in prevalence, then I will show you easily how you can actually do that directly in Atlas just by using a cohort definition. Turns out that the computation of a prevalence is actually pretty straightforward, and so long as you can define what your denominator population is, then you can actually apply an inclusion criteria to represent that numerator, and the standardized output of an Atlas cohort definition will give you your prevalence estimate. So I have prepared examples of walking in incidence rates, incidence proportions, and prevalence in Atlas to show you how that could work for a multiple sclerosis example. But before I do that, let me stop here and ask if there are any questions about the conceptual definitions of these before we go on.
All right, I'm gonna stop here in case we have any questions. Yeah.
All right, thank you. Thank you. So I think that was really great kind of to go through what's the difference between the prevalence and incidence. And then I think, Patrick, I like the last slide, which is really, of course, we all like cheat sheets. So that's easier when they use what and how to kind of on a high level, how to do that. So any questions from the audience? So I know, like, just from like experience before, like I feel like it's always kind of a default question besides, cohort, how many do you have for disease A, in your data? And then that's like the first question to ask. And then pretty much the second or third question that people are going to ask for disease A or something is going to be, like, what's the prevalence? And sometimes I know people's understanding a little bit different, like, what do you mean? Because I think I found it a hard way that better to like clarify between what data scientist view of prevalence versus EPI's view versus a doctor's view, or all the different parts. But I think like Patrick said, there are already either way, like we have different ways to do that, but I think the last thing we wanted to do, because I think we've done, like I know people have done it before, is that you never really, because we have the data report of, data A has like 1 million patients, but that's a static number. Like that person, like you never really use that for any prevalence or incidence calculation, because I think that's a common mistake that we've seen. And it's kind of, even when we talk to people, they're like, but you have the total number. What do you mean? You have to do additional calculation to have the, prevalence or incidence, but then it's not the same thing versus a static number or the denominator in your incidence or prevalence. Any questions from the audience? Or just comments?
Hi, Song here, Patrick. You mentioned that in some time in the future, we might implement the recurrent cases, calculating the recurrent incident rates in Atlas. Is it something in the near future, or as a non-tech person, I prefer to use the web atlas to go through the stuff. It's very much straightforward. It's really easy to use. So just wondering if it's something that will happen in the next few months, or is it a long-term milestone that we have in development? Wondering if you know.
Yeah, so it's a good question, Song. So I think in terms of realistic expectation, I would think it is a measure of months, not weeks. Part of it's on the roadmap to be done, but one of the things that we're actually trying to work on within the Atlas web development framework is to make sure that we're actually using the OHDSI R packages that we develop as being the main thing that does the computation, so that we don't end up with two sets of code. So one of our problematic areas that we have right now is that inside of Atlas, there are certain ways that things get computed. And then inside of our OHDSI packages, there's a different way to compute things. As a general frame of reference, I'd say like the OHDSI approaches are correct. That's the area where we're doing the more rigorous mathematical evaluations and unit tests to make sure that everything's kosher. And so the incidence calculation in Atlas is completely valid for the use case where you only care about first occurrence of events. And in my experience, that is greater than 80% of the cases I've ever encountered. So I don't want to discourage people from using it, because it's a very, very helpful and reasonable tool to use. But in the case where you need recurrence, as of today, the answer would be use the cohort incidence R package and just do it directly. And I would imagine in the next few months, at some juncture, there's going to be a release of Atlas whereby the cohort incidence R package will be the thing that is actually called by Atlas to do the exact same computation.
So just a follow-up question. So Patrick, will that be calculated within Atlas, or it will be like, PLP or PL, it will be, export and then run it in R?
Yeah, so that's one of the things that the Atlas Web API work group is actually talking about, is how exactly that works. So there, for those who have installed the Atlas tool, some of you may have experienced that you can install it in such a way that you can configure it such that you can call an execution engine. And Odysseus has helped various organizations with doing this, where the execution engine basically grabs the command that's going to be called and sends it directly to R and executes the package and sends it back.
Okay.
And so that's what actually happens with estimation and prediction right now, and that could feasibly be done for this incidence rate. Right now, the incidence function that is called inside of Atlas doesn't actually have to go out to an execution engine. It can be called directly through Web API as a SQL statement, but the cohort incidence package is actually doing some more sophisticated manipulation. So it actually is a standalone package. So it would likely be the case that evolving the Atlas, we're going to end up in a situation where Atlas is really designing the specifications that get passed into OHDSI packages. And then the question when it comes to your Atlas configuration is whether you've installed it in such a way that you can take advantage of calling an execution engine that uses the R packages, rather than expecting that Atlas out of the shelf will do the analysis for you.
Okay. So I'll be still relying on the R computation, whether it's linked to the web API of Atlas, or it's...
Yeah, I mean, I think longer term, like within the next year or two, you're going to see that as we evolve Atlas, that's kind of the direction we'd like to go, is to have standardized input specifications designed by a web interface like Atlas, such that we can really rely more primarily on the OHDSI R packages as the way to do these analysis.
Okay. That makes sense.
Thanks. I think Mark is raising his hand.
I was raising my hand, and sooner or later I'll figure out how to put it down, but that will be after my question. There are a number of people on here who are data partners within the Legend Diabetes study. And one of the first deliverables from Legend Diabetes is looking at incidence of different users who are starting on different diabetic drugs. And amongst our discussion, we're interested in reporting how these incidents across the different drugs might vary across drugs or over time, or across different subpopulations within the cohorts, those with cardiovascular disease and those without. And we're kind of at an impasse in the tools that cohort incidence package itself provides, because when we want to start making these comparisons, we need some estimate of the variance of what these incidence rates are. There are certain measures which just use kind of the standard error based on an incidence rate, which might be appropriate for some of the smaller databases where that standard error can be very big. But what advice do you have for providing real measures of uncertainty in incidence rates using the OHDSI tools, particularly when you want to make comparisons? And, you know, I have the reviewer number 2 in mind who says, yes, you know, I want some sort of formal test here. You know, how can we do that?
Yeah, it's a really good question, Mark. I'm gonna start with my minority opinion about this question, because I have a strong opinion about a topic that I know that I'm not in the mainstream about. So it is very, very common that when one wants to compute an incidence rate, they have an expectation that they're going to produce an incidence rate with an associated confidence interval. And I believe that like I was classically trained, and I'm going to guess many on this call were classically trained, like that's a thing you do. You produce an incidence rate with a confidence interval. And the problem with that traditional thinking is that if we don't examine the core assumptions about what an incidence rate confidence interval means, we can actually be tremendously misled. And very specifically, the very core statistical assumption that's made is that your data source itself represents a random sample from some generalized population that you are trying to draw an inference from. And so if you treat your database as a sample of some underlying population, then you could assume that whatever rate you've observed is some Poisson distribution that you can logically compute a confidence interval for. The problem is that I don't believe any of the databases we have across the OHDSI community actually are random samples of anything. I instead believe that Jing has access to the IQVIA open claims data set, and it is a defined data population that is just a direct observation of a phenomenon that is not a sample of anything. And similarly, at any of the databases we have, I don't believe any of us have actually legitimate random samples of any population that can be well defined. So very purposefully, and I'm willing to take the heat and the criticism for this, we don't make our tools as a generic output, as a default, produce confidence intervals based on assumptions of random sampling in variance in general populations. That said, we do provide case counts and denominators, which means that if you want to appease reviewer number 2 on your paper, you can follow a Poisson distribution and produce a confidence interval. And indeed, I am guilty also of publishing papers where reviewer number 2 asked me for the confidence interval, and I just really wanted the paper to be done with, so I did the necessary thing to just get the paper done. But I really want to challenge everybody to think critically about why are you doing the statistical analyses you're doing and what kind of inference you're drawing. When we are doing characterization analysis, which I will assert is our incidence and prevalence analysis, I don't believe we are trying to draw an inference of any sort. We're actually just trying to directly observe what happened to patients, in which case the question about what does variance mean is actually a tricky question, because we're not trying to infer what happened to the next patient or the next population or the next sample draw from a generic population. We're actually answering the direct question, like, what happened in Korea? What happened in Japan? What happened in China? And from that perspective, I would actually assert that the answers we produce are deterministic. We observed a certain population that observed a certain number of outcomes, and that is the answer to the question with no statistical uncertainty. That said, we can absolutely observe variance in the effect that we are looking at, and we can understand the heterogeneity across our data sources. So as all of you are thinking about studies of incidence rates and prevalence, I just encourage you to think about how we can compute the estimate in such a way that we make sure that we're being clear about whether we are characterizing what we have observed across our databases versus trying to infer what we would expect to observe in some future population.
Thank you. I can obviously kick back on some of those points, but I'm not. But I wanted to get your opinion on it. Thank you.
I will just state as a very clear, reinforce my preface. I know I have a minority opinion on this topic, and so you should pay attention to reviewer 2 or whoever else talks to you about it, because there is a prevailing thought that no matter what you're doing, you are producing a sampling frame from whatever database you have. I don't think that most of the databases in our OHDSI network are, in fact, random samples of anything.
Nope, they are not random samplings. Okay, cool. Thank you, Patrick and Mark. So just look at the time. We have about 20 minutes left. So I think we do have, for the prevalence part, as Patrick mentioned in the last video there, what we could do that kind of easily with an atlas, and then we will. So if you could, maybe we can play the next part, which is the demo of atlas. Sure. Of how actually we could do that.
All right. I'm gonna play where it left off. Please do stop me if you don't hear the sound.
Mm-hmm.
Yeah, so let me go through this demo real quick. And everything I'm going to show you is in Atlas. And I just want to orient you to the differences between incidence and prevalence as you go through this. So just as an example, I am showing a cohort here, which is persons with multiple sclerosis. I don't want you to pay attention to how exactly we define multiple sclerosis. I just want you to think of that as a disease that we created a cohort for. In this particular case, I'm taking all people at their earliest time of having a diagnosis of multiple sclerosis. And just to show how the logic fits together, I've created an inclusion criteria that says that these people must have a second diagnosis of multiple sclerosis or a treatment for multiple sclerosis sometime afterwards. So you can think of this as a prevalent cohort, that it's finding all people at the very first time that they had some record, and they must have some sort of secondary record that kind of is an indicator that they actually have the disease. So here I've defined all the people in the database who ever have multiple sclerosis, according to this logic. Now, if I was interested in creating a prevalence characterization, I would need to define my target population of interest. And so this is what Chan was asking about. So here I've defined a target population, which is just people who are in the database on January 1st, 2018. And I'm requiring that on that date, January 1st, 2018, they must have at least 365 days of prior observation. And just to demonstrate the point, said one day afterwards. So they got to be in the database on January 1st, and they got to make it to January 2nd of 2018. Given this, I've now defined a specific moment in time. 2018 is my moment that I'm asking the question, what is the prevalence? And so one could say on January, there's this notion called a point prevalence, which is to say on January 1st, 2018, what is the prevalence of multiple sclerosis? And the way we could think about computing that would be to say, now that I've found all the people on January 1st, 2018 who are in the database for at least a year, I could basically just determine what proportion of them are in our multiple sclerosis cohort. So just the overlap of those two cohorts gives us the answer we're interested in. In contrast, if I wanted to define an incidence, well, I can't have the people who had pre-existing multiple sclerosis in their records because we are looking for new outcomes. And a person who's already had the disease is not eligible for having the disease again. So here, if I wanted to define my denominator, what I could do is say, identify people on January 1st, 2018 with 365 days of prior observation and 1 day follow-up, but I would add a, I'm sorry, I'm looking at the wrong cohort. I want to show you this one, sorry. I would add an initial event which says, and they must not have multiple sclerosis anytime on or before January 1st, 2018. So this basically is eliminating the people who have pre-existing disease. And the reason I would do that is because then I'm left with the denominator of people who are eligible to have a new outcome. So the difference between the target population for the prevalence and the target population for the incidence is the removal of the pre-existing disease. So I'm going to show you, let me just, okay. So now I'm going to show you how we estimate prevalence. So given my, I'll flip back to it, given the target population, which is January 1st, 2018, all I'm going to do is I'm going to add an inclusion criteria. And my inclusion criteria is going to be, has multiple sclerosis prior to or during the year 2018. So I'm going to use the same logic I defined in our cohort, but now I'm putting it inside of an inclusion criteria. So I'm saying it has at least one occurrence of multiple sclerosis, where on that date I have at least one more multiple sclerosis diagnosis or a treatment. And I'm requiring that this occurrence happens anytime before and up to 365 days after the January 1st, 2018 date. So this is going to be able to tell us what proportion of people in our denominator satisfy this criteria of having had multiple sclerosis. And if I generate this cohort in any database, I ran a couple just to demonstrate it. I don't know which database I just picked. I picked the Optum database. What you will see is that the Atlas cohort definition just explicitly gives you the answer to your question about prevalence. It's telling us that there was 11,947,730 persons at risk, and of those, 39,725 had the disease or developed it during the year 2018. So therefore, the prevalence, the actual number, if you wanted to have one to report, 0.33% is the prevalence. That's the proper prevalence estimate for this particular disease. And so if you want a prevalence, you can just get it directly out of Atlas by creating your target population, defining the disease that they have to have during whatever interval, and then the number that comes back will be your answer to the prevalence question. In contrast, if we wanted to define an incidence in a cohort definition, then we could go through the process of taking our denominator, applying our inclusion criteria, and what we would get at the end would be, scroll down here, there we go, would be an incidence proportion, in that what it would be telling us is the number of people who are at risk as the denominator, which is 11,909,468, And then it would be telling us the number of new outcomes, which is 2,117. And that means that what the tool tells you is the incidence proportion, which is 0.02%. So that's number of persons with a new outcome divided by number of persons at risk. I'm showing you this conceptually. I want you to remember the number 2,117, but this is one way you could think about it. However, if you are doing incidence rates and you are doing a chronic non-recurrent event, you can actually just explicitly use the incidence rate tool in Atlas. And when you use this tool, you can add your target cohorts. You're going to notice that I've added two here purposely. I added the prevalence cohort of persons with prior observation, and I also added the incidence target cohort, which is and no prior multiple sclerosis. And I'm doing that just to show you how this tool actually works. I then added our outcome, which was persons with multiple sclerosis. And then I've defined my time at risk as 1 year. So I'm using 365 days from the index date, which we know is January 1st, 2018. And when we run the incidence rate package, you will actually see for our cohort here, Optum, that case number 2,117. That's that same number we got when we used the cohort, the cohort definition. But what's different and what's better about this particular tool is that you not only get the incidence proportion, which is 1.78 per 10,000 persons, but you also get the incidence rate, which is telling you the number of outcomes divided by time at risk, which in this case is a similar number of 1.92. So in using the incidence rate package, you are getting both metrics, the incidence rates and the incidence proportion. And depending on the amount of time of interest, like if you define a 3-year time horizon, those numbers could pretty substantially diverge. Now, the other thing I wanted to show you is I highlighted here, I've selected, in this particular case, the prevalent cohort, but if I select the incident cohort, you're going to notice these numbers don't actually change. And you might be wondering, well, something's wrong with the tool or what's going on, but that's because what the incidence rate package actually does is it creates a requirement. I'm going to go back to the definition to show it. It creates a requirement that you cannot exist in the outcome you cannot exist in the target cohort if you've already existed in the outcome cohort. That is to say, if you have pre-existing disease, you have multiple sclerosis before January 18, you're definitely kicked out no matter what, because you're not eligible to have a new outcome. And so the reason why you see that these counts are not changing between our prevalent cohort and our incident target cohort is because the incidence rate package itself is doing the correction for getting rid of the prior outcomes. So as my recommendation to you all is if you are interested in producing an incidence and you are working on a chronic non-recurrent disease, then create a target cohort like we did for the prevalence, which is just like 2018 with a year of prior observation. Define your outcome as just all the outcomes and let the tool take care of cleaning up the pre-existing disease and figuring out what are the new outcomes. It does a really good job of solving that problem for you. If, however, you are dealing with acute recurrent events, then you should not use this tool because that assumption about first occurrence may not be appropriate for you. Or if you are computing prevalence, is the metric that you are interested in, then you don't want to use the incidence tool, but rather you'd want to go back and think about how to compute the prevalence directly in your cohort definition. I'll just show it just as reference. The cohort incidence package is out on the OHDSI GitHub repo, and Chris Knoll is the maintainer of this, but he provides instructions for how you can install the package and call the execute function by passing in cohorts to do that if you are not using Atlas. I know that I was kind of long.
So Patrick, you still have to define the cohorts in Atlas, but then you run the R packages by just giving it like that cohort number at the top, right?
That's exactly right. Yeah. So,
okay.
So
cool.
the primary thing that we were solving by creating the R package was handling all of the complex situations where in your target cohort, you could enter and exit multiple times, and for your outcome, you could enter and exit multiple times. And it does some extra bells and whistles, but basically that's the real thing that we're trying to overcome, the limitation that's currently in the Atlas version.
And it still does the same thing where that if so what you just showed earlier, where if you're in the outcome, it will already remove you from the population to begin with, right? Regardless of how many times you enter.
So it has some extra parameters. So it basically allows you to say, how long do you want to look back and remove a person? So it's a little bit, it's a more advanced set of parameters to let you do that.
As a look back period. Okay.
Yep.
Ooh.
So I know that was probably a super fast whirlwind tour through there, but I'm happy to answer any questions if anybody has any. So,
all right, thanks. So, I think that was great, kind of just demonstration of kind of how we could use Atlas to do most of that without coding or, running in R or anything like that. And I know it's kind of, we have a couple more minutes left. Any questions from the audience on the Atlas part? All right, and then I think then we will give everyone 3 minutes back, and thank you so much, Patrick and Mark, for staying up late for this call.
Thank you, Patrick, for enduring listening to yourself again.
Yeah, that was painful, but if anybody does have any questions, or if there's anything I could help you all with as you're working on your studies, please don't hesitate to reach out. That's why Mark and I are staying up late, is because we're here to help you all.
Thank you so much.
Thank you, Mark.
I just want everyone to know it's Patrick who's staying up late. It's not even 9 p.m. here. And it's an excuse to skip the bedtime ritual. and to help promote good research in the APAC community.
All right, cool. Thank you guys so much. And we'll be posting the recordings of this call on the APAC page. Thank you guys.
Thank you.
A good rest of your day. Bye.
Bye.
Bye-bye.